There we go. All right, so the title of your notes, you can add it to your other notes on separable equations or start new notes, it's up to you. But what we're doing that's different is we're solving them today. So before we try some examples, we're just going to write out the steps that we'll take to do each problem. So the first step is going to be to separate the differential equation. Do you guys remember what I mean by separate the differential equation? Yeah, it's like you're getting all the things that have to do with y on one side and all the things that have to do with x on the other side. When do you know if an equation is separable or not? Yeah, factored. It's like something where you could take all the y's and multiply them to the other side, or take all the y's and divide them to the other side. You cannot add or subtract, unless you can take like the whole thing over. Okay. Step 2 is to integrate both sides. And we're going to write, don't forget the plus c. The third step is to solve for y. And we're going to say, if possible. The problems are more interesting if you can actually solve for y, so I'd say most of the ones we're going to do are solvable for y, but every so often we'll run into one that's a little bit too complicated for us to solve, and then we'll just leave it there. So solve for y. And then fourth step, if they give you a point like an initial value, they say that this is a point that's on the graph, then you can find c. So either we're going to leave it here and just call it a general solution and have a plus c in the equation itself, or if they give us a point, then we can plug that point in and solve for c. So they might have just the 3 steps, or they might have all 4 steps if they give you a point. So the last step would be to find the value of c. When given an initial value. Alright, so for the first example, we're going to have dy dx equals x times y. And what would we do to separate that so all the y's end up on one side and all the x's end up on the other side? We would what? I think I heard it. So we typically put the y's on the left side, right? So how do I move this y to the other side? Divide by y. So if the coefficient over here is a 1, I can tell that it's a 1 because there's no number there. Then, and divide the y over, that would give me 1 over y when I divide it over. And I'll go ahead and I'll leave the dy there. And then what would I have done with this dx? Multiplied it to the other side. So the x stayed there, and then I just multiplied it by the dx. Okay, so step 1, separate the differential equation. That's what we just did. Step 2 is to integrate both sides. So we'll integrate that side and integrate that side. So what is the integral of 1 over y? I remember this one has the trick. I think you just said it. It's ln, yeah. So this one is ln of y. And this one shows up quite a bit, so you got to remember it. And then when we integrate, what do we always put on the end? Plus c, right? And what's the integral of just plain old x? We've got an exponent of 1. So we add 1 to it. So it's 1/2 x squared. Good. And then what should go on the end? Plus c. So when you integrate, this just means that there's a constant floating around in the problem somewhere. The constant, it's not necessarily like c is a variable we're solving for. C at this point is not a specific value, it's a general value. Like there's some extra number in there that when you integrate like wouldn't necessarily have shown up. So it is not required to have a C on both sides. In fact, it's going to confuse you if you have one on both sides because you would have combined like terms and moved it over to one side. Does that make sense? Like when you solve this, you're not going to have like a +1 and a +5. You would have just put 4 on one side, like a -4 on one side or a +4 on the other side. So when we do this problem, we're just going to go ahead and ignore the c that goes with the y because typically we're solving for y. So we are not going to say I can subtract the c over and the c's cancel. We are not going to say that because that's a general c. That's not a specific value. That's just in general. It means we have a number on the end. Okay. How do I get rid of the ln? Does anyone remember what undoes an ln? E, yeah, E undoes it. So we're going to put E right here and E right there. So E to the ln, those things cancel out and you just get Y. And then this part over here is real tricky. We're doing an example like this one because these show up a lot, so it's not going to be uncommon for you to have ln y equal something and for you to have to solve for that y. That will not be uncommon. So we've got e to the 1/2 x squared plus c. That plus c is part of the exponent now. Do you guys remember how exponential rules work? When do you add exponents together? Yeah, when you multiply, right? If you had x to the 2nd times x to the 7th, what would you get? X to the 9th, and you would have gotten that because you did 2 plus 7. So what we're going to do is we're going to kind of go backwards. We're going to do the backwards version of this and say if we have two things that are being added right now, it really means that it was the same base with different exponents and those bases were being multiplied. So I'm going to say that right now this is e to the 1/2 x squared times e to the c. So I did like backwards exponential rules, right? Now e to the c is still representing just some number, some constant there. So I'm going to say that c is the same thing as 5 times c is the same thing as c minus 2, which is the same thing as 57 to the c power. All those are the same thing because it doesn't matter right now what the c is. That c is a general term. Does that make sense? It's not specific. So if you have a constant and you multiply it by 2, it's still a constant. Does that make sense? It's still just a number. If you have a constant and you raise it to the 5th power, it's still a constant. It doesn't all of a sudden get a variable. So if we have e raised to a constant, overall this is still considered to be a constant. Does that make sense? So e to the c doesn't really mean anything to us. We're going to say that this is still just c. It still just represents some number. It could be a decimal, it could be a whole number, it could be anything, but it still just represents a number. Does that make sense? We're going to do that a few times so you'll be able to see it again. So for this one, we're going to say that our general solution to that differential equation is a coefficient of c, whatever that number happens to be, that's the constant, and then e to the 1/2 x squared. Okay, let's go ahead and do another one. So this one is going to say that we are doing dy dx equals x squared over y squared, and it goes through the point 0, 2. So step 1 is to separate those equations. How do we separate them? Yeah, so we can multiply the y squared to the other side, so that gives us y squared dy. The x squared is still there, right? And then what would have happened to that dx? Yeah, it's over here. You would have multiplied it over to the other side to get all the x's. Okay, so we separated the differential equation. Step 2 is for us to integrate both sides, and remember to put plus c on one of those sides. So I'm going to integrate that and integrate that. So what happens here? Yeah, 1/3 y to the third. Do we need to put a plus c here? No, technically no, because we're just going to put it on the side with the x's. It only has to show up in the problem one time. What do we have on the right side? 1/3 x to the third plus c. Okay. So what can I do to get the y value alone? Multiply it by 3. So I've got to multiply this side by 3. What's 3 times 1/3 x to the third? It's just x to the third. And if I have a constant and I multiply that constant by 3, has it become something different than a constant? It's still a constant, so I'm still going to write plus c. So again, I did not write 3c because this c is not a specific variable. It represents that there's some number sitting there on the end. That's all it represents. So if I have c or 3c, it still just represents a number. How do I get y alone now? I think I heard it. Cube root? So y equals the cube root of x to the third plus c. So there's our general solution that represents all of the solutions to the differential equation. How do we find the specific one that we are looking for? Plug in the point, right? 0, 2. So 2 goes in for y, and 0 goes in for x. So 2 equals the third root of c. And how do I undo that third root? Yeah, cube it. Raise it to the third power. So c equals 8. So then we're going to say that our specific solution is third root of x to the third plus 8. How are your brains doing with this stuff so far? Pretty reasonable? Okay. Now that you're comfortable, we're going to do a trig problem. No, every time. So dy dx equals 6x over 2y plus cos y. So if we separate the differential equation, what do we have first? And I'm going to make sure to put all of that in parentheses, because the dy applies to both of those things. So we separated it. What do we do next? Yeah, we not differentiate. We're going to integrate it. So what is the antiderivative of 2y? How do you integrate 2y? Y squared. And what's the antiderivative of cos? Sine. Okay, and I'm going to ignore the plus c for now. I'm going to put the plus c on the other side. And then what should we get over here? 3x squared plus c. Okay. Is this going to be a problem where we can solve for y? No, because that's nasty. So we're going to leave it. See, that wasn't so bad, even though there's trig in it. Not terrible? No? All right. The next one, we're going to say y prime is x divided by square root y. What's another way of writing? What's another way of writing y prime? dy dx. Yeah, so I'm going to rewrite it that way so that I can see my y's and my x's more easily. And then what do we need to do so we can separate it? Yeah, so we've got root y dy equals x dx. And we're going to integrate both sides. Is it easy to integrate a radical that looks like a radical? No, what should we write instead? Y to the 1/2. Good. That's easier to integrate. Okay. So y to the 1/2, what do we do to integrate that? Add 1. Divide by, what's 1/2 plus 1? 3/2. Okay, so divide by 3/2. So 2/3 y to the 3/2 equals 1/2 x squared plus c. Okay, so we've got to solve for y. How do we get rid of the 2/3? Multiply by 3/2. And then we're going to multiply the other side by 3/2 as well. So those cancel, and we just have y to the 3/2. And what happens when I multiply these two fractions together? 3/4. 3/4 x squared. And then what happens when you multiply 3/2 times a constant? Is it still a constant? Still a constant, so we're still going to say plus c. Okay. You might have to reach further back in your brain for this. How do you get rid of a 3/2 exponent? You can, so we could do it with square roots, but it's a little bit harder. You can raise it to the, think about how exponents work. So if I have an exponent raised to another exponent, what do you do with those? You multiply them, yeah? Like if we had done x to the 2nd raised to the 3rd power, you guys all would have been like, oh yeah, that's x to the 6th, right? Okay. So we want to multiply this by a fraction that's going to make the fractions cancel out. So 2/3, yeah, we're going to raise it to the 2/3. And if you raise the left side of the equation to the 2/3, what do you have to do to the right side? Same thing, raise it to the 2/3. So we're going to say our solved equation is 3/4 x squared plus c, and that whole thing is being raised to the 2/3. Does anyone know why this 3 over 2 didn't do anything to change the c, but this exponent of 2/3 includes the c? Anyone know the difference between those two? So why did this 3 over 2, when I distributed 3 over 2 to the c, it didn't actually do anything? But then when I did the 2/3 out here, I'm letting the c stay inside the parentheses. Why am I just not ignoring the c and putting parentheses here and putting the 2/3 right there?
It's going to be a constant either way, isn't it?
Yeah, it's going to be a constant either way. Why does it matter? Yeah, it has to do with your order of operations. So this is meaning that we have the 2/3 power means that you're kind of, it's like you've got 2 sets of parentheses, and then once you FOIL out those 2 sets of parentheses, you would third root it, is kind of what it means. So that's why the c has to be inside the parentheses. So you'll notice there's a difference between taking a number and multiplying it by c, or taking the entire group and raising it to an exponent. Does that make sense? So we did something to the entire group. The c is included in the entire group. We did the same thing if you look at example number 1. We did the same thing here where c was part of the group. So c was part of that whole exponent we had up there because it was part of the group. Does that make sense? So we let whatever it is that we're doing, it includes the c if the c is part of the group that it's happening to. Before, if we were asking ourselves the question, like, does 5 multiplied by a constant still equal a constant? Well, the answer to that is yes. So those are like the more simple ones. Does that kind of make sense, the difference between those? I think some of it is intuitive. I just want to make sure that you guys are not getting confused on when that is. One more example, and then we're going to call it good. So this one, we're going to do another one that has a point. So we're going to say dy dx equals 1 minus 2y, and we're going to go through the point 0, 2. So can we just take this and add 2y to the other side and call it good? No, we can't, right? We can't add or subtract. You can't add or subtract over, you have to multiply or divide. So how could we move this over to the other side with the y's? By multiplying or dividing something. We can't break it up, right? We can't add or subtract it over. So that means the whole group has to either stay or the whole group has to go. So it's got y's in it. That means the whole group has to go. We've got a coefficient of 1 here. So we're going to divide it over. We're going to say it's 1 over 1 minus 2y, right? We're going to leave the dy on this side. If we took the right side and we divided it by itself, then did it leave a 0 in its place or did it leave a 1 in its place? It left a 1 in its place. So we're going to say this equals 1, and then we would have multiplied the dx over. Does that make sense how we thought of it? So we divided the whole group over 1 over the whole group. Okay. So now we have to integrate both sides. And what do you guys remember about this integration on the left side right here? It's rough because you guys are a little bit rusty. You might not remember. We've got 1 over something. That means eventually we're going to have an ln. But it's not a plain like 1 over y or 1 over x. It's got other stuff. Do you guys remember what we do if it's got other stuff? It starts with a u. U substitution. We got to do u substitution. So the u is the entire thing on the bottom. So the u is 1 minus 2y. And what is the derivative of 1 minus 2y? Negative 2. And do we see a negative 2 inside this problem? No. So we're going to have to divide by negative 2. So I'm going to rewrite that integration. I've got a negative 1/2 in the front of the integration sign. And then inside of it, I'm going to say 1 over u du. So that's going to be the one thing about these is if you are rusty on integration, you're going to need to have your notes out for integration maybe so you can remember some of this stuff. Specifically on u substitution, you might want to have your yellow sheet out so you can look up old rules if you need them. But all the antiderivative rules are fair game. U substitution is fair game. So what is the derivative of 1 over, or the antiderivative of 1 over u? ln, yeah. So we've got negative 1/2 ln u. And what's the antiderivative of 1? X. We got the plus c in there. And then what do I do instead of writing u? Yeah, I replace it with the 1 minus 2y. So I've got negative 1/2 ln, I'm going to replace that with 1 minus 2y. Okay, so our goal is to do whatever we can to get that y all by itself. So what could we do first to start getting y by itself? Yeah, we can get that negative 1/2 to go away. What's the easiest way to get it to go away? Yeah, I'd probably multiply by negative 2. So now I have ln of 1 minus 2y equals, what do I get when I multiply that negative 2? Negative 2x. If I take a constant and I multiply it by negative 2, is it still a constant? Yes. So plus c. Okay. Now we have to get rid of the ln. How do we do that? E. So on the left side, the e and the ln cancel, and we just have 1 minus 2y. On the right side, we have to be really careful about how we write that because the plus c is part of this group. Right? So we have e to the negative 2x plus c. And last time, if you look back at example 1, see if you can remember how we dealt with this in example 1. Yeah, we separated them. So I've got 1 minus 2y equals e to the negative 2x times e to the c. And what did we say about e to the c? It's still a constant, right? It still represents a constant. So we've got 1 minus 2y equals c e to the negative 2x. Subtract the 1. Good. So we have negative 2y equals the right side. Subtract that 1. Divide it by negative 2. All right, and then they gave us a point to plug in, right? So, so if we plug in that point, we're going to say 2 equals c times e to the negative 2 times 0 minus 1 over negative 2. What's this part equal right here? E to the negative 2 times 0. That equals 1. So we have 2 equals c minus 1 times negative 2. Times the negative 2. So negative 4 equals c minus 1. C equals negative 3. Whew. Okay, so we have our specific answer that goes through that point is going to be negative 3e to the negative 2x minus 1, all divided by negative 2. And you might be noticing that's an awful lot of negatives, right? So it's possible, let's say you were doing this as like a multiple choice problem on an exam and your answer, this answer was not in there. Do you know what answer would have been in there if they canceled out all the negatives that would cancel? Every sign would switch, yeah. So it would be positive 3e to the negative 2x plus 1 divided by positive 2. And that would be like you took the top and factored out the negative, and you took the bottom and factored out the negative, and the negatives canceled. So this is a valid answer, this is right, but it would also be right to have the negatives cancel and have a slightly different answer. Whew.